name is Alejandro, and welcome back for day 20 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for August 5th, 2024, and let's get straight into it. Okay, so today we get a LeetCode easy. Sweet. Problem 2053, Kth Distinct String in an array. Okay. A distinct string is a string that is present only once in an array. Okay. Given an array of strings R and an integer k, return the kth distinct string present in R. If there are fewer than k distinct strings, then return an empty string like this. Okay. Note that the strings are considered in the order in which they appear in the array. Okay, relatively straightforward. Let's take a look at an example. Input R, k equals 2, so what? Output A is, oh, A is not the third. Okay, D, B. Okay, wait, B, okay, so B happens again. Okay, so D, B, C, B, C, A. Okay. Okay, the first thing that comes to mind then is because it won't be this, okay, so the very first thing that comes to mind, well, first of all, it's using hash sets, but I was gonna think of just doing like one scan and just using one hash set. I think, well, okay, we can come up with a solution now and then do something more optimized later. So for now, what we can do is kind of just do two parsings of the array R, right? So what we're gonna do is say we're gonna keep track of a distinct set. So and scene equals set, right? So for R, for num in R, first of all, we're going to say scene.add num, right? For every number that we visited in R, we're going to put this into our scene set. And then what we're going to say is this, okay. If num not in scene, this is the first time we see num. So distinct.add num, right? Otherwise, second or more time we see num, and we're going to say distinct.remove num. Right? Oh, and okay, sets won't preserve an order, and then if I do an array, then it won't be efficient in terms of popping elements. So we can just do that for now. Then we could just do something like this. Then we can just say scene. Is there a clear function for sets in Python? Let me just, whoops, there's, so if I do Python 3, and then I'd say like s is equal to set with 1, 2, and 3 here. I have s, and if is there a clear function? Okay, yeah, so that empties a set. So we're going to do scene.clear. Basically, I just need a new hash set, and now that we've populated distinct, we don't need the scene set anymore, so we just do scene.clear. For num in R, we're going to do scene.add num if length of scene is, what's the restriction of k? K must be at least 1. Okay, so good. If length of scene is equal to k, then return num. Wait, are we returning a string? No, num. These are not numbers, right? For letter. But why is this AAA here? Oh, for string. Okay, for string in R, or we'll just call it num, but like, well, here, num string. There we go. So now clear for string in array. Scene.add string. If length of scene is equal to k, then return the string, otherwise we return an empty string. So I wonder if something like this works straight off the bat. Wrong answer. Okay, so let's think about it. Here d of b print distinct, comma scene. Oh, we want to only we only do this if string in distinct. Yeah, sorry. What was the point of populate indistinct otherwise? Let's see if something like that works. Okay, and let's run the code. Whoops. Distinct or remove string. Well, that's not possible, right? Use test case. This is bizarre. Yeah, sometimes I wish I had that debugger in LeetCode. That would be quite helpful. But if string not in scene. If string not in scene, yeah, okay. Otherwise, we must have added scene before. Assert string in indistinct. Dang, okay. So that's very interesting. How is that possible? How is that possible? Like the idea here is that I do scene.add string, right? For every string in an array. So if string is not in scene, that means it's the first time we see the string, right? And then we're gonna add it to the distinct, and then add this to our scene set. And the idea is like if we see it again, then we're gonna remove it from our string set, because this will be the clause that we reach, right? Oh, it's just that I might have removed it once. Oh, okay. So it's like, let's say the second time we see the string, we do remove it from distinct, and then the third time it's no longer in distinct. So it's like, hey, what are you trying to remove? So we'll do if string in distinct. We can even do an elif here, although I think it makes the code less readable actually. This logic is easier to understand. But there we go. Yeah, that makes complete sense. Otherwise, this should work. Okay, very nice. Well, that's essentially it for the solution. We can see if maybe we can try to do something a bit more clever. Okay, 76%. This likely means it's a little optimized. Yeah, our memory is very bad. So let's think of wait, that surprises me. Whoops, not solutions. That's not what I want. 76%, and that's with looping over R twice. Obviously, it's still O of N, but I'm trying to think, how would you do this with just one loop, right? So it's like you've seen D, but you have no idea if D is distinct or not. And you're gonna have to how could you do this with just one set and one parse, right? Let me think. D could happen at the beginning and the end of the array. So it's like maybe you populate, it would be nice to populate kind of like a set where we keep track of an ordering, right? Maybe we could do a dictionary and we keep track of the indices that we saw stuff, right? But then we'd have to loop through everything in the dictionary, which at most would be O of N. I mean, this is a pretty good solution otherwise. Here we can change this to an elif. Yeah, this is exactly second time. Is that more or less readable? I guess maybe having the comments inside. I think outside is usually preferred, but here it just makes it easier. But the point is that we have the scene array, so it's like we keep track of every single number that we see. And then, yeah, this is fine. Scene.clear. I mean, this is perfectly fine. Okay, yeah. Well, we can keep the solution. The solution is totally all right. To kind of explain what I'm doing, it's this, right? So the problem says like, we want to find the kth distinct string present in R, right? And so how are we going to do this? If we look at an example like this, we have our first character is D, right? And k equals 2. And we might think like, oh, okay, we just need to look at the next element that's not distinct and so on, and we'll get it right away. Well, think about this. What if D also was at the very end of the array, right? You won't know until you go to the very last element in the array that D was actually not a distinct element. So my original idea was, okay, how about we do 2 parsings of the array? The first parsing, we're going to keep track of which strings are actually distinct, right? So we're going to keep track of this set, distinct. And essentially what we're going to do is for every element we pass by, we're going to say, okay, if this is the first time I've seen it and so on, which means I keep track of this seen set, which every iteration that for every string I go inside of R, I'm going to add something, I'm going to add that string into the array. But before I add the string, I first check if it's already in seen. If it's not already in seen, this means that this is the first time I see this element in the throughout my for loop here, right? So for example, starting with D, this will of course be the very first time I see D, right? And so because of that, I will say maybe it's distinct, maybe not, but for now I'll just pretend that it is distinct, and I'll add it to a set called a hash set here that I call distinct, and just add D into it, right? And then I'll come see B, and I'm like, okay, this is the first time I see B as well, so I'm going to add that in my distinct set. Then I see C, okay, first time I see it, put it into my distinct set. So my distinct set right now has D, B, and C. But then I see B again, right? And inside my code here, because at the end of every for loop iteration, I add every string I see into seen, when I get to B here again, it will necessarily be inside of my seen dictionary, right? And then I say, okay, well, in that case, since it is in seen, I'll check first if it is indistinct, and if it is indistinct, I'm going to remove that string from the distinct set. And the reason I check if it's specifically indistinct is, let's say that this wasn't the second time we saw B, but the third time. Well, the first time I'll have added it to distinct. The second time I'll have removed it from distinct. The third time it's no longer from distinct because I already removed it, so that there's nothing to remove, right? So, but the idea is that since I've seen B before, it will no longer be in my distinct set. So the only things that are in my distinct set are D and C. And then I see C again, so nothing is my, so C will be removed from my distinct set and only D is in there. A, first time I see it, so I add it to the distinct set, and then that's it. We've parsed everything. So in our distinct set, we just have D and A, right? But since it's a hash set, there's no specific ordering to this set, right? So I can't just return like, hey, give me the second element in the set, right? That's just not going to work. I could try it, right? So it's like I can do return distinct of K here, right? And if yeah, so set object is not substrictable, right? That's the whole idea. A set doesn't have an order; it's a set, and so or a hash set. And so what I do is like, okay, now that I have my distinct array populated, first of all, I could do a little optimization. First of all, if length of distinct is less than k, then I could just return empty string, right? And so on. Here I can do raise exception unreachable code, right? And so I could do something like this. I'm pretty sure this will work, right? If I do less than or equal, this should fail, and so on. I just want to make sure. But the point is that like this has k, yeah, exactly. So, and if I submit something like this, I think it should work. Very nice. Okay, but the idea is this, right? We've populated our distinct set, right? And then, of course, we want to return the kth distinct string that we saw in our array. But again, we don't have an ordering of the elements from the distinct set. We just have the elements themselves. Now, of course, if the number of items inside of this distinct set is less than its value k, then there is no kth distinct string, right? There are less than k total distinct strings, so we can just return empty string as they said if there are fewer than k distinct strings. Otherwise, then we know that length of distinct is greater than or equal to k, so it has at least k elements. So we want to make sure, okay, let's find the one that the kth distinct one, right? And so the way we're going to do that is we're just going to keep build a new hash set. Instead of creating a new hash set, I just cleared the seen one because I'm not using that one anymore. And so this just essentially makes it empty. And then I'm going to reparse through all of R again. And then I'm going to say, okay, I only want to keep track of the distinct strings themselves, right? So D at the beginning, I see, oh, this is a distinct string. This is great. Then I'm going to add this to my hashet. Here it's seen again, so we'll just call it seen. But like, okay, D was in my distinct set, so I'm going to add D into my new seen set, and now I've seen one of my many distinct elements in the array. Now when I get to B though, B is not a distinct string, right? It's not in my distinct set from when I did my first parsing. So I'm going to ignore B and so on. And I'm just going to keep going through all the elements until I find one that is indistinct again. So like here, A and so on. And at any point, if I say, if the number of elements that I have seen is equal to K, that means I just saw the Kth distinct string, right? And so what I want to do is, okay, return string. Again, this is a hashet, so even if you add an element, so even if I saw D again and I just added D to the hashet again, there will only be D once in the hashet. The whole point is because it's a hashet. And so you don't have to worry about that little edge case. So whenever the length of this seen hashet becomes K, it's because I just added the Kth distinct string that's present in R, because again, I'm parsing R from left to right. And then that's essentially it. So I just return string. That's the solution. We can press submit. Again, here it's just I do raise exception unreachable code, because this will necessarily this piece of code will necessarily trigger, because we know that we keep adding into seen strings that are indistinct from array, and we already covered the condition where the length of the strings is less than K, and so this will forcefully execute. And yeah, that is essentially the entire solution. So in that case, I hope that was very useful. This was day 20, so I'm good and right on track with these LeetCode daily challenges. If in case you do want to do something similar to what I do, the extension that I use is called LeetSync. Essentially what these guys do is whenever you press submit on a LeetCode problem and it's accepted just as is here on screen, then it will automatically push the code that you just wrote into your GitHub repository. So I can show an example of this to you. Here, Kth Distinct String in an array, we can come in here and we'll do Kth Distinct, yeah, right here. You'll see 3 minutes ago on the side here, but essentially it'll post a copy of the README. 10 minutes ago is when I first submitted the problem, but here's the README to the problem submitted, as well as my newest submission from LeetCode added onto here. So I trust this extension myself, but by no means does this mean that you have to trust this extension yourself. It just happens to be very, very useful in case you want to do something similar to what I do. But other than that, that's pretty much it for today's daily challenge. I hope it was useful or entertaining for you to watch, and in any case, I'll just catch you next time. So, ciao, ciao, my friend.